In this unit, let's talk about objects that reflect or absorb specific colors, right? So, and how we're able to observe objects that are colors. So, in our simplest example, I'm sure that everyone has been outside on a hot sunny day and wearing a black t-shirt and discover that you're uncomfortable because your shirt feels hot. Well, black is absorbing all of the spectrum from the sun. All of that white light energy is being absorbed into that surface and converted into heat. And so the black t-shirt tends to feel hot. The white t-shirt, a white t-shirt now is reflecting all of that spectral energy, all of the spectrum that's coming from the sun, and is cooler because it's not absorbing all of that heat energy, right? So we talked about white and we talked about black. Black absorbs everything, white is reflecting everything. But what about blue? What about your blue jeans? Well, your blue jeans are absorbing the red spectrum and the green spectrum, but they are reflecting to our eyes the blue spectrum of light. So that blue pigment is able to reflect blue light, but absorbs all of the other colors, right? So if we were to shine red light at our red sweater, it's absorbing the blue and the green spectrum, but is able to reflect the red. Now we're outside in the park with the trees and the grass that are all green. And those green objects are able to reflect the green spectrum, but are absorbing the blue spectrum and the red spectrum. So let's take a look at this in a little more detail, right? So if I have a red apple with green leaves and I shine a red light at it, right? The red light is bounced off of the red apple and we see the apple is red. However, the green leaves are unable to reflect any of that red spectrum and therefore appear to be black. Now, if we were to shine a green light at our red apple with green leaves, the red apple is going to absorb all of that green light energy and it can't reflect anything back. So it appears black or gray or dark. And we can't really see the color of the apple. The green leaves, however, can reflect all of that green energy and we will see the leaves as green. If we were to shine a blue light at our red apple with green leaves, no energy can be reflected to our eyes. The red apple will absorb all of the blue spectrum and the green leaves will absorb all of that blue spectrum. Then they'll both appear to be black. Now, if we move into a more complex color or a secondary color, cyan, cyan will absorb the red light energy and reflect the green and the blue. Magenta is going to reflect the red and the blue, but absorb all of the green. And yellow would reflect the red and the green, but absorb all of the blue. And we spoke about black and white. So this is a little bit about how colored objects either absorb or reflect light spectral energy. So I will be back in a few.